Hi all, welcome to Sidza.com. Now in this video we will learn about the solution. Solution is actually a mixture. We know when you react the two components, suppose if you mix the component A and the B, and if the two substances combine chemically they react. If they react, what you get? You will get a compound. Okay, you can get a compound. And a compound has a different properties than its reactants. This will be a totally different substance. But if you mix the two components here, A and the B, but they don't react, chemically they don't react. Chemically they do not react. If they don't react, then what you will get? You will not get a compound, you will get a mixture. So when you mix two things and they don't react with each other, what you get? You get a mixture. Mixture normally is of two types: a homogeneous mixture and a heterogeneous mixture, right? So we get a homogeneous mixture and a heterogeneous mixture. Now what is the homogeneous and a heterogeneous mixture? Before we actually explain what is a homogeneous and a heterogeneous mixture, we can take certain examples here, right? Suppose if you mix the sugar in water, right, what do you get? You get a mixture. Okay, this is a mixture, but what type of a mixture it is? It's a homogeneous mixture. And the solution refers basically to the homogeneous mixture. Solution is what? Solution is the homogeneous mixture. Correct? Similarly, if you take the salt and the water, right, you take the NaCl, you mix it with the water, what do you get? Again, you get a homogeneous mixture. So this is again a solution. But if you mix here the sand with the water, we again get the mixture, but it's not a homogeneous, it will be a heterogeneous mixture. But what actually is the heterogeneous mixture? What is the difference between the homogeneous and heterogeneous mixtures, right? Primarily, the difference between the homogeneous and the heterogeneous mixtures is the size of the particle, right? It is the size of the particle. So particle size actually distinguishes between a homogeneous and a heterogeneous solutions. If the particle size is less than 10 angstroms, remember this point. If the particle size is less than 10 angstroms, okay, it will be a homogeneous mixture. Say this is the homogeneous mixture, and the particle size, suppose you are taking the water, and in this water I am going to add here the NaCl, right? In NaCl solution, this will be a homogeneous mixture because here the particle size is very, very small, correct? You cannot see this even under the simple microscope. Okay, so that is the homogeneous mixture. But if the particle size is more than 10 angstroms, it's a heterogeneous mixture, right? So if the particle size is more than 10 angstroms, the solution will be called as heterogeneous mixture. Heterogeneous mixtures are of two types, further two types. One is a colloidal solution, another one is a suspension solution, right? In a colloidal solution and another one is a suspension, right? Both are heterogeneous, but again there is a difference, right? If the colloidal, in colloidal solutions, in a colloidal mixture, actually the particle size is more than 10 angstroms. Between 10 angstroms, we can say between 10 to 1000 angstroms, right? 1000 angstroms. So if you have a particle size which is between 10 angstroms to 1000 angstroms, right? This is the range. It's a heterogeneous mixture, but you know what type of heterogeneous? It's a colloidal, right? It is a colloidal, solution. And if the particle size is more than 1000 angstroms, right? It's more than 1000 angstroms, it will be called as a suspension solution, right? This is a suspension. Example, we can see the milk here, right? The particle size is, a little bit bigger, but you can't even see these particles, these particles which are there, solute particles, you can't see them with your with your eyes, but you can see these things under the the microscope, the simple microscope. And in the suspension, example here is it will be a muddy water, right, or the sand water. Suppose you got the sand and the water, you can see these particles very clearly with your naked eyes. Okay, particles are visible to our naked eyes. Both these solutions, whether it is colloidal or the suspension, it's a heterogeneous mixture, right? Both are heterogeneous. So in this chapter, we are going to discuss only about the homogeneous solutions, right? So we have, this one is our topic, the homogeneous solution. Another point about the homogeneous and the heterogeneous solutions is, homogeneous mixture, right, actually it has a uniform distribution throughout, correct? That means if you suppose you got the sugar solution here, right, and you got the sugar solution, which is a homogeneous mixture, the composition that you find here will be exactly similar that you find here, right? The composition will be same throughout. But in a heterogeneous mixture, the composition is not same, right? It's not same throughout. It's not uniform. They have the localized regions with different, properties. Okay? And normally, when we refer to the solution, it actually refers to the homogeneous mixture. So when I talk about the solution, it means a homogeneous mixture, not a heterogeneous mixture. For heterogeneous mixtures, we have different terminologies. One is colloidal solution, the other one is suspension. So when I say simply solution, it refers to the homogeneous solution, homogeneous mixture. Hope you got the concept. Thanks for watching the video. Bye for now.